When you start studying the topic of building a recirculating aquaculture system, RAS fish farm, you are faced with a huge number of questions. It's about fish and biology, equipment technology, construction, sales, paperwork, and so on. And it seems like everything is gradually coming together into a clear picture, but this picture immediately falls apart as soon as you start actual construction, because reality always looks a little different than what you originally planned. All the most expensive mistakes are usually made not with the fish, but already at the construction stage. And even a simple mistake in the foundation can cost you millions and months or even half a year spent on reconstruction. Hello everyone, my name is Anton Pelcher. I am an engineer and have been building fish farms for over 10 years. Be sure to watch this video until the end, because in it I have gathered almost 15 years of my experience and put together a kind of unified and coherent checklist that you can follow and use as a guide when building your own RAS fish farm project, which can save you months and months of hard work, as well as millions, if not tens of millions of money. So let's get started. Of course, this entire checklist mostly does not apply to a small home mini farm that can be set up in a backyard in a month or two. This is still more relevant to large industrial farms. Nevertheless, the key points in it are common to farms of any size. And so, let's move on to the first stage. These are preliminary design solutions. What does that mean? Let's say you want to build your own fish farm. And the very first thing you absolutely need to start with is the appearance of your farm, with a concept based on basic figures. Because if you don't understand what you're growing, in what quantity you're growing it, where you're basically selling it, and at what price, how can you plan what kind of equipment to include in your farm? I think it's difficult to make any further decisions including design without this. You can't just jump straight into design without even having a rough idea of what you want to design. So at the stage of preliminary solutions, what's created first? Yes, this is chosen precisely. The farm's capacity is determined, the type of fish is selected, and so on. How many units you will have on your farm, whether you will have your own incubation or not, what weight you will grow the fish to. In other words, the first concept is related to the production plan. Second, based on this concept, which is tied to the production plan, calculations are made for the entire system. How many tanks you need for the incubation larval unit, the juvenile unit, and the grow-out unit, and what their sizes should be. What technological equipment needs to be selected for each unit? How will the fish move through your system during its life cycle? And naturally, in the end, you get a clear and understandable calculation of the RAS system and an equipment specification. The next step is the layout of your facility. In order for you to understand what kind of building needs to be constructed and to calculate the basic building costs, you at least need to know its dimensions and how the equipment will be arranged. That's why, at this step, the layout of your entire facility is created, with all the tanks, utility rooms, and technological equipment arranged. Next, once you have the concept of your fish farming plan ready, all calculations and specifications completed, and the layout finalized, you need to determine the resource consumption. That is, what electrical capacity you need, what heating capacity, what water capacity is required, and how much wastewater will be discharged. This gives you an understanding of which plots of land are suitable for your needs and requirements, as well as what expenses you will incur for connecting utilities. And probably the final stage is calculating the economics. That is, you need to understand what your financials will look like. And this also includes questions related to sales. In other words, you need to decide where you will sell this fish, at what price, and also what the economics of your farm will be, if, of course, that's important to you. That is, calculations are made based on a real farm. Electricity costs, heating, seed stock, feed, personnel, all of this is calculated, meaning a basic staffing schedule is created. The cost price per kilogram of fish is calculated. You take the price at which you plan to sell it, calculate the profit per kilogram, and estimate the approximate payback period. This way, even before you move on to the design phase, which is already a later stage, you at least on your fingers, or well, a bit more thoroughly than that, you'll be able to calculate whether it's even worth getting into this project, whether your site meets these requirements, whether your existing building is sufficient, whether you have enough money to implement such a project, whether the resulting economics appeal to you or not, and whether you'll be able to find, acquire, and purchase the necessary equipment, and so on. In other words, this concept is where you work out the future project for your farm, but at a very early stage, so that if something isn't right, you can either tweak it, change something, or even abandon the project altogether before you're in it up to your elbows. And yes, the usual standard time frame for completing this first stage is about 1 to 2 months, provided there are no delays. Let's move on to the next stage. This is exploration for water. Before you even start any construction or design, I would recommend that you first determine whether there is water on your plot. Because I have actually encountered situations where people said, yes, everything is fine with the water, there will definitely be water, everything is good. They would start the design process, begin construction, and only at that point would they drill an actual well and realize that there was either very little water or the water was of really poor quality. And that's when the disappointment set in. Then they had to look for workarounds, drill more wells, search for water, install all sorts of systems, even up to reverse osmosis for water purification if the water wasn't suitable. So, in the end, it turned into a pretty complicated ordeal. But why go through all that if you could have drilled in advance and realized there was no water? Or if the water is bad, you could simply choose another plot with much better conditions than here. That's why I recommend you drill a well, take a water sample, have it analyzed in a lab for all the main contaminants, and don't forget to test the water as well. First, measure its temperature right there on the spot and check the yield, that is, the amount of water the well can provide. And yes, as for the timeline, well, drilling a well usually takes from 1 week to 1 month. Generally, it doesn't take that long. Now let's move on to the next stage, which is the technology project. Yes, you heard right, a technology project, because before moving on to designing the building, and especially before starting construction, I always recommend developing a technology project. This is because it's not the building that determines the conditions for fish farming. That approach works with existing buildings, but it's not always optimal. If you are constructing a new building, then the technology sets the requirements for the building, its dimensions and its height, the depth at which various reservoirs are located, the floors, the foundations. And in this case, what does the technology project provide? It finalizes all the parameters of the building, everything I just listed. It provides a very important aspect, drawings of all the concrete floors and reservoirs, because a fish farm is not just a flat poured floor, and then something is just placed on top, like some barrels. But in reality, these are water treatment reservoirs, which can be large and are better embedded in concrete, right below the zero level. It's an entire web of utilities which are better not placed on the floor, so people don't trip over them, but ideally should be embedded in the floor, either in channels or under the concrete. In other words, the floors are the most important part of the building, and it is precisely this aspect that is worked out within the technological project. This technological project also sets the requirements for everyone involved. This includes water supply and sewage, electrical systems, heating, architecture, and reinforced concrete structures. In other words, it provides the technical specifications for all related designers. So if your builders take on the design of the hangar's engineering networks, the first thing they'll ask is, give us proper requirements. And requirements made up on the spot, like, you need 100 kilowatts of electricity, won't work for them. You need to specify which point, how many kilowatts to supply, what phase configuration, and so on. Which point to bring in the water, what diameter, where to route it, how to distribute it, and where to direct the sewage from. And the only solution to provide all this to them is a technological project. Is it possible to do without it? Probably you can do without it. But how you would solve these issues on an industrial farm, I can hardly imagine. Well, it's a different matter on a home farm probably, when you don't have any designers at all. And everything is done on the fly, in some kind of room. In that case, sure, you can do it however you want, simply. But not on an industrial farm. Usually a technological project takes quite a lot of time. On average, it takes from 3 to 5 months. The next stage is to bring in electricity. That is, if there isn't a ready-made transformer substation on your site, and you need to bring electricity to the plot, don't forget about this stage, because usually bringing in electricity is not a quick process. It might take 1 month to connect, or it might take up to half a year. This is a serious issue. You need to be sure that you will be able to bring in the required amount of electricity before you start construction. Conduct a site survey. Well, let's say we've found water. We've already conducted these surveys. But in addition to this, it's necessary to conduct a soil analysis, because it's the soil analysis that will give the building designers an understanding of what kind of foundations they need to lay. And often environmental studies are also conducted to determine the impact on the environment. This is especially important if you plan to draw water from an open water source or discharge it into an open water source. As a rule, surveys take about 1 to 2 months. The next step is preparing the construction site. Well, before building a hangar, you need to prepare a place for it. That is, things like access roads, if they are needed. You might need to fence off the site just to be safe, so that nothing goes missing during construction, and to station a security guard. You may also need to carry out some landscaping work, remove soil, or add fill. All of this needs to be done right now, at this stage. Yes, the site preparation stage usually takes more than a month and a half. Next comes finally the general construction project. That is, the entire site has been thoroughly checked. All surveys have been conducted, the project documentation for the technology has been completed, water has been found, and electricity has been connected. Now you can start working on the project for the general construction part. What does that mean? Well, at the very least, you can get by with just the design of the hangar itself. That is, these are metal structures, reinforced concrete structures, in sections such as water supply and sewage, heating, ventilation and air conditioning, and electrical systems. In other words, the minimum required utility networks. This is the basic minimum needed so that later everything can be installed by someone. And yes, such a project typically takes 3 to 5 months to complete. Obtaining a construction permit. So now we have a complete set of all surveys, design documentation, technology, and the project according to Decree 87. What's next? You need to obtain a construction permit. And here there are 2 possible scenarios. Or rather, even 3 scenarios. The first scenario, you don't need to obtain a construction permit at all if your project is a reconstruction. For example, you take an old existing hangar and reconstruct it, even if that hangar practically no longer exists and has been demolished. The most important thing is that it still exists in the official documents. In that case, you carry out its reconstruction. It already exists in the documents in the cadaster. You simply restore it within the same dimensions. Then everything is as straightforward as possible. This is the second scenario. For new construction under 1,500 square meters, you need to obtain a construction permit. You submit the project documentation and obtain this permit through a simplified procedure. And third, the relatively most complicated option is undergoing an expert review. That is, if your building is over 1,500 square meters, if your property is located in any specially protected natural areas, if your plot has some special designation, or if you draw water from open bodies of water or discharge into open bodies of water, then you will need to undergo an expert review. This could be a standard expert review, or it could be an environmental expert review. It might be a state review, or it might be a non-state review. Accordingly, this is what you will need to go through. Therefore, actually obtaining a building permit is a fairly quick process, taking 1 to 2 months. If we are talking about an expert review, it can take 3 to 4 months, and sometimes even longer. We are finally approaching the actual implementation of the project. First of all, this involves ordering the equipment. I have often encountered situations where entrepreneurs and clients would first build the hangar completely from start to finish, with floors, all the works and engineering systems, and only then would they start thinking about how and what equipment to order. And as a result, some people had their hangars standing empty for half a year, others for a whole year. To prevent this from happening, and so you don't have your money tied up for such a long period, usually equipment ordering and construction begin at the same time. 90% of the items are custom orders because in a recirculating aquaculture system farm, especially an industrial one, the components are not just lying around in suppliers' warehouses. It's very important to understand this. In order to outfit a small farm with equipment usually takes from 1 to 3 months. To equip a more or less industrial scale farm starting from 1,000 square meters, it already takes from 3 to 6 months, and sometimes even longer if the project is larger. Therefore, in principle, the delivery of the equipment itself is, in terms of timing, equivalent to the construction of the hangar itself. And yes, while not everything has been built and set up yet, I recommend that you also take care of another issue, digging a biopond. If you are going to discharge sediment, runoff from your settling ponds, bioponds, then I recommend digging these bioponds in advance because the soil from them will be used before landscaping or taken away. In general, it will be more convenient for you to do this at this stage. Well, basically, digging a pond takes a couple of weeks, up to a month at most. The building's foundation, we will break the construction process down into stages a little bit. Everything always starts with the foundation. That is, for the already designed hangar, you need to build the foundation, and at the same time, by the way, don't forget to order the hangar itself. Option 1, a concrete slab is poured and the hangar frame is mounted on it. Option 2, a strip foundation is made, the hangar frame is mounted on it, and then the floors and concrete reservoirs are poured inside afterwards. I recommend the second option and I'll explain why. On one hand, it seems like double the work, but on the other, you can build the hangar and at the same time do everything you need with the floors inside, because the floors in fish farms are something you need to handle very carefully. If you do something wrong, it's almost impossible to redo it later. Concrete tanks and piping grids are embedded into the floors, so it's not just a flat concrete slab. The floors are much more complex. That's why, as a rule, the assembly of the hangar and the pouring of all the concrete elements inside, including the floors, are done in parallel. The next stage of the flat foundation is pouring the concrete tanks. As a rule, the industrial farm tanks and water treatment reservoirs are installed separately. They are embedded in concrete because they are large and bulky and water needs to be supplied to them by gravity. Generally, it makes more sense to build them in concrete. And right now, this is exactly the stage when these reservoirs need to be constructed. Because once your hangar is closed, it will be almost impossible to bring in construction equipment and everything will have to be done by hand. But right now, you can bring in an excavator, concrete pumps, and anything else you need. The time required to pour concrete reservoirs is on average about a month, provided your workers are not working too slowly. At the same time, you can start assembling the frame of the building itself. So, while you are constructing the concrete reservoirs, another team is working in parallel to assemble the load-bearing metal structures of the hangars. And once the reservoirs are poured and the skeleton of the hangar is assembled, it's time to pour the floors. Because later, once the hangar is closed, it will be almost impossible to bring in the equipment. So at this point, you pour the floors. The floors are poured taking into account the trays and the utilities embedded in the floor, meaning all the preparatory work must be done in advance. And pouring the floors is a matter of, a week at most, but generally it can be done in just a few days. So after pouring the floors, we move on to closing up with sandwich panels. The sandwich panels are pre-manufactured and pre-ordered, and you use them to enclose the hangar. Honestly, there's not much to comment on here. The time frame for this is, maybe about a month at most. Well, finally your hangar is enclosed, the floors are poured, the pipes are laid, and the tanks are installed. Now it's time for the engineering networks. Because in order to start installing the technology, you need to create the right conditions inside, which means having electricity. Inside the building, you need to have lighting, water, and a temperature of at least 15 degrees, so you can, for example, weld the same plastic. That's why now it's necessary to bring in all the engineering systems. We start with electricity and lighting, then bring in water. The sewage system should already have been embedded in the concrete in advance. Naturally, because at this point it would be impossible to lay it in anymore. Only the external networks can be installed now. Ventilation comes last, and of course heating as well. That's everything you need to do to make sure your hangar is fully ready. And of course the interior spaces, they come by default together with the frame. As a rule, it takes about 3 to 4 months to complete all of this. And now we move on to the installation of the technology. We now have a finished hangar with all the engineering systems installed and connected where needed. Now you can install the technological equipment that has arrived. We take it, and usually everything starts with welding the pools, which actually begins a bit earlier. The pools are welded, and then all the technological equipment is installed in its designated position and connected with pipelines. Only after that is it filled with water and tested. This is essentially the installation process of the technology. Yes, all the electrical connections are also brought to this equipment and the control cabinet is installed. After the technological line is assembled, which takes from a month for small farms to 4 to 5 months for larger ones, on large, serious farms, this can happen. After that, the equipment is commissioned. Everything is run, tested, and started up to ensure that it fully meets all the required parameters. And one of the final stages is starting up the biofilter. You either need to add reagents for the chemical startup of the biofilter and let it settle for about a month to a month and a half, or you can start up the biofilter directly with fish. And yes, don't forget to order the stocking material in advance, even at the construction stage of the hangar, because if you build everything first and only then start looking into the stocking material, you might be disappointed, since you'll be told that you should have ordered the fry or eggs 2 to 3 months earlier. To avoid this situation, please make sure to order the stocking material several months in advance. Feed is a much simpler issue. As a rule, it is available at the fish farm, but stocking material is not always available. Hiring a team? At the very beginning of construction, I recommend hiring 2 key people if we are talking about an industrial farm. These are the chief fish farmer, the person who will be responsible for the fish, and the chief engineer, the person who will be responsible for all the equipment you have on the farm. Ideally, these two key people should be present during construction, so that they participate in the building process, so that by the time the farm is launched, they know every valve, every pipe there. And they should have a clear understanding of how to operate it, because an unprepared team at the launch of the farm is a very, very bad thing. And if the key people know what to do with the farm, then the rest of the staff can be hired. In fact, this can be done closer to the launch of the farm. And that's when the stage of team training begins. At that point, you can calmly proceed with systematic team training, including hands-on instruction from the chief fish farmer and the chief engineer. Well, now the final stage is approaching. The hangar is built, everything is filled, engineering systems are connected, equipment is installed and running, the biofilter is operational, the team is assembled, the stocking material is ordered. What else is left? Well, basically, that's it, stocking the fish. Prepare in advance for stocking. Check the quality of the stocking material you ordered from the supplier by visiting the supplier directly, monitor the delivery, and supervise the unloading. Congratulations, your farm is up and running. Well, that's about it. Today I tried to cover the main key steps for building and launching a fish farming operation in a single video. If you found this helpful, please support this video with a like. Also subscribe to my Telegram channel and check out this video. This was Aquaculture with my channel about how to raise fish and make good money from it. Bye.